Quite often in A-level maths, you get a sort of modelling question. So this is a modelling question using the cosine graph. So James wants to construct a model for the height of the tide during the day using a cosine graph to represent the way the height of water changes. He knows that the first high tide of the day measures 10.85 metres and occurs at 2 a.m. The first low tide measures 1.65 metres and occurs at 8:15 a.m. James uses T for the time in hours past midnight and H for the height in metres. He models the tide using radians, so you should make sure you read the question carefully because sometimes it says degrees, with the equation H is equal to 6.25 P cos AT plus B. First thing we've got to do is show that P is 4.6. Okay, so we use the fact that the high tide is 10.85 metres and the fact that cos goes from -1 to 1. So the high tide will occur when cos is 1. So when cos AT plus B, doesn't matter what A and B are, is equal to 1, this equation here will become 6.25 plus P times 1 is equal to 10.85. And if we rearrange that, we're going to get 4.6 as required. We should also check that the low tide, so the low tide is at 1.65 metres. So when cos AT plus B is equal to -1, that will happen. That's when the low tide will occur. We can say that 6.25 plus P times -1 is equal to 1.65, and that will give also, if we rearrange that, P is 4.6 as required. So we can definitely say that P is equal to, and we're definitely showing that P is equal to 4.6. Right, show that the first high tide to occur at the correct time, 2a plus b will be equal to 0. So if we look at the cosine graph measured in radians, so the cosine graph looks like that. The high tide occurs at 2 hours. So we can say if t is equal to 2, then h would be equal to 6.25 plus 4.6 cos of 2a plus b. Now, for this to give the high tide, this bit here would have to be equal to 0, because cos of 0 gives 1, and that will give the value of the high tide. So 6.25 plus 4.6 is cos of 0. Okay, and that will give 4.25 plus 4.6 times 1, which gives the 10.85, which we know to be the high tide. And therefore, hence, we can say that the high tide will be 2a plus b will be equal to 0 as required. Then it says, use the time of the first low tide to form an equation relating to A and B. So the low tide will occur at 8:15 a.m. Now, got to be careful because it says 15 a.m. We need to change that into hours. So it's 8.25 hours. It's 8.25 hours. And therefore, 8 plus t plus b would be equal to pi, because that will be the value where we get -1 for the low tide. Cos of pi is -1. Okay. You can see that from the graph. So we have to say that that happens when 8.25 a plus b would have to be equal to pi. Right. Hence show that a is 4/25 pi and find the exact value of b. So if we use our two equations we've got from the two previous parts, we've got 2a plus b is equal to 0 and 8.25a plus b is equal to pi, and then did a subtraction. So we're going to get 6.25. So we're going to do 2 take away 1. The b's will cancel, and we're going to get that's equal to pi. We're going to get a is equal to pi over 6.25. You should try to avoid getting into decimals here. So pi, that becomes pi over 25 over 4, which is 6.25, which means that pi is 4/25 pi as required. And then if we substitute that into either 1 or 2, obviously 1 is much easier, we're going to have 2 times 4/25 pi plus b is equal to 0, and that will give me that b is -8/25 times pi. So we got our two answers here. A is 4/25 over pi as required, and then we've got b is minus 8 over 25 pi, and therefore our equation h will be equal to 6.25 plus 4.6 cos 4 over 25 pi t minus 8 over 25 pi. Right, James can only sail the boat when the height of the tide is more than 3.95. So use the model to predict the range of times that morning he cannot sail. Okay, so if we take our equation, okay, and then what we need to do, we need to solve this for equal to 3.95. So we've got 6.25 plus 4.6 cos of 4 over 25 pi t minus 8 over 25 pi is equal to 3.95. If we subtract 2.6 minus 6.25 from both sides, it comes 4.6 times 4 over 25 pi t minus 8 over 25 pi is equal to minus 2.3. And then if we divide by 4.6, we're going to get that the cos of the bit in the middle here is going to be equal to minus a half. So we've got to solve this equation. So if we do cos to the minus 1 of plus a half, we know that to be 60 degrees, which is pi over 3 in radians. Don't forget we're working in radians. If we do our South Asian Tennis Club or cast diagram, we want to know where it is negative. So cosine is negative in the second and the third quadrant. So we draw our angles with the x-axis pi over 3. We're going to get that our angle, which is 4 over 25 pi t minus 8 over 25 pi, will be equal to pi minus pi by 3 and pi plus pi by 3, which means it will have to be equal to 2 pi by 3 or 4 pi by 3. Okay, so writing that out again. Right, so we now make the t the subject of this. So we're going to add 8 over 25 pi. So when we do that, we're going to get 4 over 25 pi t. This one, when we add 8 over 25 pi. So on your calculator, you should just do 2/3 plus 8/25 using the fraction button. That'll give you 74 over 75 pi. And then similarly here, 4/3 plus 8 over 25, just adding the pi. That'll give you 124 over 75 pi. And then we'll need to divide by 4 over 25 pi. So don't forget the pi's will now cancel out. So on your calculator, you just do 74 over 75 divided by this using the fraction button. It'll give you 37 over 6 and 31 over 3 for that one. That will give you, as a decimal, 6.16 recurring hours and 10.3 recurring hours. But you should note that 0.16 recurring times 60 is actually 10 minutes. And 0.3 recurring times 60 will be 20 minutes. So the times will be 6:10 a.m. and 10:20 a.m. So some statement at the end. The range of times the boat cannot sail is 6:10 a.m. to 10:20 a.m. Now, there's a GeoGebra app to go with this video, and the link will be in the notes of the video. So here we have our tide function. You can see following the function, we have the high tide here and the low tide here. Okay, if we on this app, if we move t, or to start it, you can see the raise and low of the tide over the time. Okay, we'll just reset that a minute. We'll just start it again. Okay, and we get a warning there because it's too low for sailing. So this is the times we've got to see. And if we want to see those range of times, then we would have to click here. And we can draw a line at y is equal to 3.95 and get the values of the times in, it should be in hours, that, not seconds, in hours. And I'll change that. And this should be 6.10 a.m. and this is 10.3 hours recurring, and this would be 10.20 a.m. Those should be hours, not seconds. Okay, that will be changed when you go to do the when you look at the app yourself. Okay, so this has been a video to show you how to do a modelling question using a trig function measured in radians. I hope you've understood, and I thank you very much for watching.